So with 5.3, solving polynomial equations, the biggest thing on this is you have to realize is that the answers can be imaginary. And we'll do a problem here in the beginning just to make sure everybody kind of remembers what that one was, as far as what we're looking at. Okay, so again, mostly not really anything new till we get to the very end and show you some things there. But most everything along the way is going to be some review of just all the different options that you could have, because again, polynomial equations is all over the board. It could be factoring. It could be like with number one, if you've got x squared equals 25. Anybody remember what to do with this one if you've got just x squared equals a number? There you go. Just take a square root of it, right? And when you square root that one, you get x equals, and again, 25 would be 5, but again, because it's x squared, and we start off with, we need two answers. So we'll put plus or minus 5. All right, this one just a little bit different, but kind of along the same lines. Let's go with x squared plus 49 equals 0. All right, first thing is, if we just move the 49 over to the right-hand side, it looks a lot like this one. So we'll subtract 49 and get x squared equals negative 49. Okay, we've got x squared equals a number. We can go ahead and square root both sides. And the biggest difference is now with the answer, we're going to get x equals square root of 49 would be 7. But because of the negative 49 with that one, we have to put the I on the variable. So this would be a plus or minus 7i. Okay, and there may be some other times where it may pop up, but that's probably the biggest time where you're going to see those answers pop up with imaginary, is when you do the square root property on both sides. If this is a negative number, just remember you have to put an I on the answer. That's really the biggest time that you'll go back and do those problems. All right, let's go for example 3. Give you something a little different on this one. So let's go x to the third equals 8x minus 2x squared. Okay, we don't even have a constant now. We don't have just x squared in number. We've got all kinds of stuff kind of jumbled up here. So probably first thing is start moving all the terms to one side. And usually it's better if the highest power, if your degree term, if your leading term, keep it positive. So in this case, we'll move everything over here to the left-hand side. And then we'll move the 8x over there as well. Okay, in most of the cases, unless it's the one like problems that we had back here, if it's just x squared and a number, those are the ones you can separate and put them on both sides and square root it. Almost every other single question, you want to bring everything to one side and let it equal 0. All right, now in most of these, when you get to here, this is going to be a review of factoring. You've got 3 terms, and now we're going to look for the greatest common factor first. Well, they all have an x, so we can take an x out. Take an x out of this one, leave you with x squared. Take an x out of this one, that'll leave you with a 2x. Take the x out here and leave you with a minus 8. All right, and now we're down to something we can actually work with in the parentheses. Now we've got just a regular trinomial in here. So once we're here, we're going to look for the factors of negative 8, where the sum would equal positive 2. All right, and only one option is going to work, because the 1 and 8, there's no way the 1 and 8 is going to work. It's going to have to be the 2 and the 4. With the b term being positive, the plus sign's got to go with the bigger number. If we do a negative 8 divided by a positive 4, that would give us a negative 2. Okay, so factoring that out, and again, the big difference is a lot of times we were factoring before, you would stop here. Anytime it says to solve, that's where we're just going to take each parentheses then and set each parentheses equal to 0. All right, we've already got the x equals 0 here. This one we just add 2 to both sides, and then this one we would subtract 4. Okay, and again, we started off back in the beginning back here with x to the third. So that was our highest power, so we have to have 3 answers. So there's our 1, 2, and 3 answers we have from this one. The other thing you can get is that once you've got your leading term here, then we had the x to the third, when we put this thing in standard form, where we had it written in descending order and everything was all nice and neat and kind of cleaned up a little bit, is that remember once you do this one, you can also use if we kind of tie back into what we were doing Monday, be Monday, Tuesday this past week, that with the first term, that if you want to do the end behavior on this one, we talk about, what's happening on the ends of the graph, that this thing was, and we'll actually do this back over here so we got a little room so not to cram it in. This was x to the third, so it was positive, and it's x to an odd power. And if we go back to that chart from Tuesday, I think it was. Yeah, I think it was Tuesday, whichever day it was. We said if your leading term was positive and x to an odd, then that meant that the right side was going to be going up, and then the left side was going to be going down. Okay, so we're going to take this one problem and kind of tie in everything that we did on Monday and Tuesday, and then kind of bring it back in today, because after a couple of days, sometimes it's easy to forget what we did back on Monday, Tuesday. Okay, so we've got our 3 solutions. If we talked about end behavior, again, we would key that on the first term, that the right side would be up, the left side would be down. And then here's what we're going to do, just a quick sketch on this. We're not going to get like a super detailed graph. We just want to do a sketch of the graph. And basically, you can go 4 in both directions and a couple of spaces up and down. You should be fine. All right, if anybody happened to have not been here Tuesday, I think Tuesday is when we tied this together. Here's basically where we're going to tie in both of those things that we did on Monday, and then the solving part and all this that kind of comes in with today. So if you missed Tuesday, we'll kind of catch you up here. How we tie all this together is you take your solutions you have and you put zeros, or you put dots at all those places. So we've got 1 at 0, we've got a solution at positive 2, and we've got a solution at negative 4. So basically, those are x-intercepts. It's where it's going to cross the x-axis. So there's 1 at negative 4, we've got 1 at 0, and we've got 1 at 2. And what we said on Tuesday, I think this is when we were doing this one, is that where this end behavior ties in with everything is that if the right side is up and the left side is down, you should go to the very most right-hand solution that you have, which would be this 2. And we know just general-wise, this thing is going to go up from there. So that's the right side up in this case. The left side says everything from the very far ends of the graph there is going to go down. So you go to the leftmost 0 that you have and the leftmost x-intercept you have, and just draw an arrow that goes in that direction there. So that's just the end behavior of a graph. That's letting you know just what this thing is going to do and all the pieces that kind of fill in with this one. And then the other thing that we added in on, I think, Tuesday was the multiplicity. We're going to put that in right underneath the bottom here. And the multiplicity said we're going to go back and look at the power that's on everything back here when we had it in factored form. Well, there's not any powers here, but those would be understood ones. So at x equals 0, that's going to have a multiplicity of 1. X equals 2 is going to have a multiplicity of 1. And x equals negative 4 is going to have a multiplicity of 1. All right, and here's the big thing we said with multiplicity. These are all odd numbers. And we said odd means when you get to those odd multiplicities, that means you go through the graph. So whenever you get to this solution that's here, you either have two choices. It's like a straight line. You can either get there and turn around and come back and stay where you are, or you're going to go through. And that's all based on the multiplicity. If it's an odd number multiplicity, you're going to go through the graph at -4. At x equals 2, same thing. You're going through the graph, so you're going this way. And the only way to get back to here is eventually, some point in time down here, this thing is going to turn and come back and do this. And then once you get to 0, which is here, that multiplicity is 1. That tells you you keep on going through it. And then eventually these two things will come back and eventually go until they meet and come back and do something like that. And as long as we're sketching it, we're not going to worry too much about how high or how low these points be. The main thing on the sketch is you know where the zeros are and whether or not you're going through it or whether or not you're going to turn around there. And we'll show you a turn around on the next one and let you kind of have an idea of what it is it looks like. Okay, so there's where we were tying everything in on Tuesday, and then here's where we're kind of bringing it back in one more time. So just kind of, putting all the pieces together here. All right, we'll do one more graph one, just kind of tie it all together. And then most of the other things, we're not going to worry about graphing these. All right, so for number 4, we'll go x squared minus 10x plus 25 equals 0. Okay, it's 3 terms, so this is where we can do some factoring here. That we're going to do the factors of positive 25, where the sum would equal negative 10. All right, and it seems like there'd be a lot more, but with 25, there's only 2 choices. It's either 1 and 25, which there's no way we're going to get to 10 with this one. So it's got to be 5 and 5. And if you've got a tie, if there's not a bigger number, then you just take this negative sign that you have here and just put it with either number. It doesn't really matter which one. And then you divide and see what you have. So now you're dividing a positive by a negative, which means the other number would have to be a negative. So in this case, they're both negatives. So it's x minus 5 and x minus 5, or you can just say it's x minus 5 squared equals 0. Right. And when we're solving this one, you set the parentheses equal to 0. And we get x equals 5. You only get one solution, but because of the 2 parentheses, basically it's a repeat answer. You get 5, and then you also get 5, so it's a double part of it. And that's where the multiplicity kicks in, because you had the same number twice up here because it repeats 2 times because you get x equals 5 here and you get x equals 5 here. That's that whole multiplicity part. But this one's going to have a multiplicity of 2 because there was 2 of the same answers. The answer showed up twice, and that's what multiplicity is. Is it saying how many times did that answer show up? Well, in that case, x equals 5 showed up twice because we had 2 different parentheses that were both x minus 5. All right, and the big thing is that with x, when you get the multiplicity of 2, which is even, that means when you graph this thing that the graph will turn around there at that point. And that's the biggest difference between the multiplicity being an odd number, where it goes through when we get there, or the multiplicity being an even, it tells you the graph is going to turn around. All right, again, we're just going to do just a quick sketch. We're not going to do like super detailed sketch here, just something enough we can kind of see what it's going to do. We need a solution at 5, so that's, wow, I still can't draw it on the next. There we go. So 1, 2, 3, 4, 5. So we got a dot right there. So that means if you've got this point, there's only two options it can be. It's either going to be like this or it's going to be like that, because it says the graph's not going to go through, it's going to turn around. And that's where, again, that knowing what it's going to do back here in the beginning, that this thing was x squared. So it was a positive number and x to an even power. And now these are the ones we were graphing before, so hopefully everybody remembers that one. If it was positive and x was even, then this thing was both up and up. So if you graph this one, just a quick sketch of it, we know it would do something like that. Okay, and I'm going to try to pick for these questions, I'm going to try to pick the ones that have multiple choice in it, because it makes it a little bit easier. Because basically you have 4 multiple choice questions. One would have a graph like this, another one would have a graph like this, and then they probably have it so that you've got another one that's back over here at -5, where you'd have one that would be like this and one that would be like this. So that way, when you're graphing these, it's not like you don't have to worry about every single little detail. The big thing is just knowing, okay, where is my solution? And then which way is the graph going? So if you can get that, then that should get you through most of the questions that we're going to do homework-wise. So I've got to make sure when I pick those problems, I pick the good multiple choice questions on those. Okay, and again, that's what the multiplicity does. It tells you what happens when you get to that point on the x-axis. If it's the multiplicity is even, you're going to turn around. Again, if the multiplicity is odd, that means whenever you get there, you keep on going through it. You don't stop, you just keep going. Okay. All right, so let's give you one here. And I want to give you this one just so you can kind of think about it just a little bit. So if you've got x squared minus 81. All right, now the obvious thing we can do is we can go back like we were doing back here with this problem, is we can just move in this case, the 81 over to the right-hand side. And we can square root both sides. And if we square root 81, that comes out to be plus or minus 9. Okay, and that's probably the way most people would do this one. Sometimes on these problems, they'll let you do that. And you don't have to do this way, but let me just show you another way, because sometimes there's more than one right way to get the answer. What's a different, can anybody think of a different way we could do this problem and still come up with the same answers? I'll give you a hint on this one. What about if we try to factor this one? Remember, if you've got two terms, with taking it again, there's not a greatest common factor, but if it was two terms, anybody remember what the other option was for factoring with two terms? It was the difference of perfect squares. Yeah. So basically, it's like square root property, but it's the difference of perfect squares. So in this case, if we did x squared, if you remember that we said that would be x times x. If you did 81, you can make that 9 times 9. But then we do one was a plus and one was a minus. Okay, so that was one. If you stuck with the factoring rules, that was something that you could do, and then you could set both of those equal to 0, and you would still get the same answers, just a little different way of getting there. Okay, so it doesn't really make sense, because sometimes people will solve it and they're like, well, I got one this way and I got the answer this way. There's not always one right answer. There's multiple right answers that you can do to get to the answer that you're looking for. So it doesn't matter whether you do the square root property or you do some factoring. Either way you go there, you can pretty much get the same answer, just depending on how you want to look at it. Sometimes you get one answer that jumps out at you one way, and then sometimes you get a different answer because you're just thinking of something else. And again, there's not a right or wrong way. It's just which way did you see it when you came up with it. All right, so let's give you one here that's a little bit different. So let's say you get a problem that starts off something like this. All right, and the biggest difference here is that it's already kind of sort of, we'll just say it's partially factored because we've already got two sets of parentheses, but we don't have x plus or x minus. It's x squared minus 1 and x squared plus 4. So it's a little different setup, but it's sort of almost kind of factored, but not totally all the way. So we'll just say it's partially factored here. All right, the good thing is we do have parentheses. So you still go ahead and set each parentheses equal to 0. But if we do that, doesn't this one look a lot like that one now? That we can, if we can take out the factoring part of here, that looks a lot like what we've got here. So for this one, we can go ahead and just move this one over and then square root both sides. All right, square root of 1 is just 1, so we get plus or minus 1. Everybody goes, well, can we just do the same thing on the other one? Yeah, we can do the same thing on the other one because it's just x squared and a number, so we can move that 4 over to the right-hand side, and then we can square root it. So x would equal plus or minus 2, but again, because it's a negative number, got to have the I to go with it. Okay, and sometimes I like to show people that one because occasionally they'll give you that one just as like they almost like do half the work for you, and then sometimes people are like, "What do we do?" You know, well, if you already got two parentheses, then you just take the parentheses you have and just set them equal to 0, so you can finish it out from there. So sometimes you get problems where they try to be helpful, but sometimes it winds up confusing people more than anything else. All right, so let me show you like two more of these, and then we've got one new thing we need to show you, and then that'll wrap us up for today. All right, so one that's a little bit different. X to the fourth minus 16 equals 0. All right, and that one's really close to kind of what we had back behind it here. That if this was x squared minus 16 equals 0, that one would be okay, right? We would just move the 16 over. We would square root both sides, and we'd get, x would equal plus or minus 4, and we'd be done. The only difference on this one is it's x to the fourth, and people go, all right, well, what do we do if it's x to the fourth? Because what do we do? Here's the catch on this one. X to the fourth, and this is where we're going to kind of go back to that perfect square part we were doing before. It's still a perfect square. So we're going to do that one kind of like we did this one when we were factoring this part of it. So we're going to factor this thing. Now, the part that makes it perfect square is that it's going to be x squared times x squared. So really the only difference is when we're going through this one, and again, if we kind of back up for a second, that we were doing this one. If we had done this by factoring, how this was two perfect squares, we said you could do x plus 4 and you could do x minus 4 if you try to factor this one. The only difference is that, this was x times x, this was 4 times 4. The only difference between these two is that x to the fourth, if we break it up, is going to be x squared times x squared. So the factoring is going to look basically exactly the same. But instead of it just being x plus 4 and x minus 4, we're going to make it x squared plus 4 and x squared minus 4. Okay, and if you can get it to where you got your two parentheses here, now you can take both of those parentheses and set them equal to 0. And then we can do that just like we did on the, now we're back to basically the same problem that we had before. That if we get it down to this point where we've got two sets of parentheses, this is the exact same thing as we had on the problem before. We're going to move this 4 over here to the right-hand side. and then we'll square root it. And again, because that's a -4, when we get finished with that one, the answer is going to be plus or minus 2i. And this one will do a +4. And when you square root it, it's not a negative number, it's just a regular 4. So that means the answer then would be just plus or minus 2. Okay, and key thing on this problem was, because it was x to the 4th, way back in the beginning, we had to have 4 answers. Well, there's our positive and negative 2i, so there's 2 there, the plus and minus 2, there's another 2 there. So there's our 4 different answers we were looking for. All right, one more of these, and then again, we'll show you the new thing that we'll do for today. Let's do x to the 3rd minus 5x squared plus 4x minus 20 equals 0. All right, a little different on this one because we have 4 terms. All right, does anybody remember the factoring rule we did with 4 terms? I do factor by, let's get the blue sheet out, they would see it there. We flip over 4 terms, it'd be factored by grouping. And when we did factor by grouping, basically we put the first 2 terms together, we put the last 2 terms together, and regardless of what the sign is, you always put a plus sign in the middle. At least that's the way I do it, because it keeps it a little bit less confusing to me if you do it that way. All right, so put the first 2 together. That's the x to the 3rd, and the minus 5x squared goes in the first parentheses. The second parentheses will get the plus 4x, and then the minus 20. Regardless of what the sign is, you always take it on the inside, especially if it's a negative. With a positive, it's not that big a deal. But if that was a negative, you'd have to take that negative on the inside with the 4x. Okay, and then from there, you just do the greatest common factor on both pieces. You've got x to the 3rd and 5x squared. Take out the smallest amount of x's that they have, which will be x squared. That'll leave you with a 1x here, and then the 5 there. Okay, with the 4x minus 20, you can divide them both by 4. And I make that x minus 5. And then that's our check, again, is that these 2 things have to be the same, which they're the same here. All right, so the x squared plus 4, when we take our GCFs, those go together in one parentheses, and then the x minus 5 will follow behind it in that parentheses. And then from here, we've got 2 parentheses equal to 0, so we'll just set both of those equal to 0. All right, this one real quick, you just get x equals 5. That's the easy part. This one, again, hopefully everybody's kind of saying the habit of it now. If we've got x squared and a number, we'll just move that over and make it a -4. And then when we square root both sides, we'll get a positive and -2, but because that's a -4 when we square root it, it'll be plus or minus 2i. All right, again, we go back up real quick in the beginning. We had x to the 3rd. So that tells us how many answers we're looking for. So there's the 1, 2 answers for the plus or minus 2i, and the x equals 5. That's the 3rd answer. Okay, so there's a lot of that's just some review stuff. And again, we kind of when we're showing you the couple of graph problems, that's where we tied everything in. You will not have to graph this problem because you cannot graph an imaginary number along with a real number on the same thing together because this one doesn't have really anything that'll go with this part. So the only way you can graph anything, we couldn't graph this problem because of the imaginary numbers. The only way you can graph anything is if you have all real number solutions. If you have imaginary numbers, then that messes things up and you can't graph those. So. All right, here's the one new thing we're going to do today. It's the last thing we'll do today. Show you a few examples on this one. And this is one of those kind of special factoring cases type thing that you'll see this once and you really won't see it very much again. And the two things we're going to show you is they're both really similar. There's basically just changing up one or two signs to make it be what it needs to be here. So the first one we're going to do is the sum of two cubes. All right, so it's going to be x to the third plus y to the third. Again, cube being that we're talking about the third power, so that's what you're going to see there. And this is one of those things that has just, this is the answer, and there's really nothing else you can do with it. It's going to be x plus y, x squared minus xy, and then plus y squared. Okay, and when we actually get to the formula, in a minute we'll give you some where you actually have some numbers in it other than just all variables, and we'll see how it would work this thing out. But this is, if you talk about just the basic formula, basic setup, this is the basic formula. This is the basic setup that we're looking at. The difference of two cubes is almost exactly the same thing, just changing up a little bit of a sign. So a difference of two cubes, instead of being plus, it's a minus. It's basically the same formula, but you're just going to change up a couple of plus and minuses back here in this formula. Okay, so sum of two cubes, it goes plus, minus, plus. Difference of two cubes, it's minus, plus, plus. That basically you just rearrange the first two terms depending on whether it's plus or minus. This sign always goes first, and then you alternate the next sign, and then from there the last term is always positive. Okay, and again, this is just one of those weird little special cases that you'll use it once every so often, and it pops up just every now and again. It pops up just enough that you kind of forget about it. And then you'll get a problem and you'll be like, oh yeah, that's that thing that I can't remember how to do. Then you have to go back and look and find out what it was, and then you go back and kind of use your formula from there. All right, so let's show you one where you've actually got some numbers on this thing so you can see how it works together. So we'll start off with x to the third plus 125. We'll start with a sum of two cubes. The first thing you've got to do is you've got to take whatever this number is they give to you and basically rewrite it. So you've got to figure out, okay, what cubed is 125? And the numbers won't be very big just because of how this thing is set up. So if you go through these and check them out, you can do 2 times 2 times 2 would be 8. 3 times 3 times 3 would be 27. Go far enough, you figure out that would be 5. 5 times 5 is 25, and then 25 times 5 would be 125. And basically, here's what you're going to do, is that wherever you have 5, you can interchange that with a y. So we're going to go back to this formula that was back up here. And everywhere we had a y, we're going to take it out and we're going to put a 5 in its place. So that's going to be x plus 5. And we're going to have x squared minus x times 5 plus 5 squared. All right, and doing that one, there's really only like one, well, I'm going to say it, two little bitty tiny things that you can do. That you've got the x plus 5 here. Usually this looks funny, so everybody will like to rearrange that and put the 5 in front of the x, so you have something like that. And then with 5 squared, make that 25. And that's as far as this thing will go. Now, somebody out there is thinking, well, why can't we go ahead and find the factors of 25 that would equal negative 5? Because there's not any. Because now you could try doing that, because that's usually the first thing we want to try to do is take this part of it. If this was our answer, we'd take this part and break it down. But if you go through 25, it's either 1 and 25 or it's 5 and 5. If you add these together, that's 26. If you subtract them, it's 24. If you add these together, it's 10. If you subtract them, you get 0. So no matter what you do, there's no factors of 25 that you can go through that's ever going to get you out to negative 5. So for this one, it seems like you could break this thing down a little bit more, but that's as far as that one will go. Because it does not factor. It seems like it should, but it doesn't. It just stops right there. All right, let me show you one more of these. And then we'll do one problem we're going to solve with this, and then that'll wrap us up for today. Let's go b to the third minus 8. They may not give you an x for the first variable. They may give you a b. Okay. And again, the very first thing that you have to do is you've got this number at the end. You got to figure out what that thing would be as something to the third power. Well, no, it's not 1. If you check 2 real quick, 2 times 2 is 4. 4 times 2 is 8. So that would be b to the third minus 2 to the third. Okay, so the b is pretty much the same thing as the x. And then the 2, we can change that out with the y. So that's kind of what we're doing in this case. Instead of having x and y, now we're going to use b and 2. We're going to plug those two things in to that equation. So instead of it being x minus y, it's going to be b minus 2. And instead of being x squared, it's going to be b squared minus b times 2 plus 2 squared. All right, and again, there's only a couple of tiny little things you can do to clean that up a little bit. Rewrite that as 2b, and then make the 2 squared out to be 4. Oh, wait, sorry, messed that one sign up. That's supposed to be a plus right there. All right, and that's all you can do. And again, there's never, the way this formula works out is you're never going to be able to find any factors of this term that equal 2. Because if you use 1 and 4, you add it, you get 5. You subtract it, you get 3. If you use 2 and 2, you add them, you get 4. You subtract them, you get 0. So it's never going to work out that you can find any factors here that'll get that. And that's just the way that formula works out. All right, here's the longest thing we're going to do there. And it's not necessarily that it's tough. It's just it takes a little bit of work to get there. That if they ask you to factor these, you just plug them into the formula, and that's all you can do. There's really not anything. It's strictly a formula type question. If you know the formula, you just plug in the numbers you have. And again, you do just a little bit of simplifying here and there, rearranging on this one, and that's all you can do. The part that gets the hardest on this one, or the longest, is they're going to ask you to solve a problem instead of factoring it. So with the solving, we got to do a little bit more work. Just like with everything else, anytime you do solving, you usually have to go a little bit more work. Same thing with this one. You're probably going to have to do just a little bit more work here. First thing is, we got to figure out what number we're using here. And with 27, that'd be 3. 3 times 3 is 9. 9 times 3 gets you 27. So instead of y that we had in the formula, now we're going to use a 3. Okay. And even though they tell you to solve it, the very first thing you're going to do is you're going to do the factoring part first. So we know that it's going to be x cubed minus 3 cubed. And then once we get this figured out that we've got this, now we're going to plug it back in and basically go back and use this formula that we're using back here. All right, so that's going to be x minus 3. We do x squared minus x times 3, sorry, plus, and then plus 3 squared. And again, there's not really much you can do with that one other than rearranging these two terms to make it plus 3x and do the 3 squared to make it 9. All right, and then to solve it, we said we would set each parentheses equal to 0. This one's really easy. Just add 3 to both sides, you get x equals 3. For this one, we've already said there's no factors we're going to find of 9 that's going to get us to a sum of 3. It's just not there. There's nothing we can do to do that one. And you may remember the backup plan. If you cannot solve by factoring or square roots or any of those things, what's the backup plan for solving quadratics? Anybody remember? One thing that works every single time, whether it's factorable or not. If it won't factor, then you have to use the quadratic formula. Everybody's like, oh, yeah. So we have to go back and use quadratic formula. So that's always your fail-safe. If factoring doesn't work, if square root property doesn't work, if all those things don't work, then the one thing that will work will be the quadratic formula. So for that one, the a would be 1, the b would be 3, and then the c would be 9. All right, and hopefully if you don't remember, we'll walk you through this one. It's negative b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2 times 8. Okay, and the big thing was, we said as long as you plug in, every time you plug in an A or a B or a C anywhere in this formula, and again, there'll be 1, 2, 3, 4, 5 times when you do that. You get 2 B's, 2 A's, and then you get the 1 C that's here. Every time you plug those in, if you put it in parentheses, we do that because it makes it easy on the calculator. And this is where we actually will go back and do the discriminant. If y'all remember discriminant, that was that number that was inside the parentheses. So we'll go ahead, or inside the square root, sorry. So if we'll go back and do this number, we'll get the discriminant, and that way we'll know what that number on the inside is going to be. So we get 3 squared minus 4 times a times c. If we do that, we get negative 27. All right, so that's going to be negative 3 plus or minus the square root of negative 27 over 2. All right, and more than likely with these, you're not going to get a perfect square root number here. So that means you're going to have to take the 27 and break it down. Now, it's a negative 27, so we know we're going to need I in the answer because of the negative that's here. So when we break this thing down, let's just forget about the I for a minute. Let's just break down 27. All right, we start to break it down. It's 9 times 3. And hopefully that one you'll kind of go, oh, well, 9's a perfect square root. So if I rewrite 27 as 9 times 3, I can take the square root of 9 and make that 3. And I'll just leave that square root of 3 on the inside. So 27 would be 3 square root of 3. If we're doing square root of negative 27, that's still going to be 3 square root of 3. We just have to put the I in there because of the negative. Now, in the way they do this one at the online homework, I did kind of check on this one. They have you put the I instead of at the end. They put it in between the 3 and the square root of 3. So they put it right behind the 3 for that part. I don't know why, but that's just where they tend to put it. Okay, and then technically we're supposed to go back and divide both of these things by 2, just in case they would simplify. But for the numbers on this one, they don't simplify. So they say, all right, we'll go ahead and break it up as 2 parts. So it's negative 3 over 2 plus or minus, and then 3I squared of 3 over 2. And they should let you use the plus or minus button on this one. When I checked it last time, they did let you do that. If for some reason they don't let you use that plus or minus button, you'll have to rewrite it at one time as negative 3 over 2 plus 3I squared of 3 over 2. The next time you do it is negative 3 over 2 minus 3I squared of 3 over 2. So there's your 2 answers for this one. And then don't forget about this one, because this was the easy part we found. You also need that x equals 3. So there's your 2 answers here. There's this one for 3, and that's why, again, it was x to the third, so you got to have 3 answers. And there's your 1, 2, 3 answers that you're looking for.